So this question in module 2 says, show that sec square theta is cosec theta over cosec theta minus sine theta. How much marks is this? Let me can judge how many steps. 4 marks. All right. Now, to do this proof, well, sec squared is equal to this. Well, we know that sec squared, so we start by saying, well, sec squared, we know that sec squared theta is equal to 1 over cos squared theta. This is sec squared theta. But since everything is in terms of cosec and sine, I'm going to change 1 minus cos squared to, I'm going to change cos squared to 1 minus sine squared. So it becomes 1 minus sine squared theta. All right. 1 minus sine squared theta. Let me see how I can generate this now. Okay. How can I generate this now? I need some sine theta here. Okay, to get some sine theta here, look what I'm going to do. I'm going to rewrite 1. I can rewrite 1 as 1 is just sine theta over sine theta. Everybody can agree with that, that 1 is sine theta over sine theta. So I change 1 to sine theta over sine theta. All right, divided by this one again. I can write it as sine theta over sine theta. And you're wondering, why am I writing out so much sine? All I did was change these 1 to sine theta over sine theta. So it's sine theta over sine theta minus sine squared theta. Why am I doing this? Again, because I want to generate some cosec. So since I want to generate some cosec, let me see if this will work. All right. I'm hoping that it will work. So now let me join the denominator as one fraction. So I can write that now as sine theta over sine theta. This is now sine theta over sine theta. Now instead of saying over, I'm going to put divide by. Now this sine theta minus sine squared theta, it's really divided by, if I were to multiply up sine theta, it's really divided by sine theta. It's really being divided by sine theta minus sine cube theta over sine theta. Let's see if this will work it out. All right, since it's being divided now, when you're dividing, you can flip it and change the sign. So I can change this to sine theta over sine theta. This is now sine theta over sine theta being multiplied by, this is now sine theta over, this is now being multiplied by sine theta over sine theta, sine squared theta. I hope it works out. Sine theta minus sine cube theta. Now let's see if this will work out. No, this sine theta cancels this sine theta. All right. Let me see. cosec minus sine. We know that. All right. Cosec over cosec minus sine. So we're trying to generate that. Let's see now. Let's see now. You don't want to have sine theta over sine theta minus sine theta minus. All right, so I'm going to rewrite this now as sine theta times, now this now right here is 1 over sine theta minus sine cube, which I can write as 1 over sine theta times 1 over sine theta times 1 over sine theta, 1 over 1 minus sine square theta. I know that this 1 over sine theta, I know that this is cosec. So this becomes cosec. This part will give me cosec. Now I need this now to generate something. Let's see what's it gonna generate. I know cosec is 1 over sine minus sine theta. All right. Let me see what I can generate. 1 over sine minus sine. 1 over sine minus sine, which is 1 minus sine square over sine. This part, which is, so 1 over sine theta, that's cosec. So let me write that. This part, this 1 minus sine theta is cosec. So that part become cosec. This become cosec theta. All right, 1 over sine become cosec. All right. 1 over sine become cosec. So now we have cosec times sine theta over 1 minus sine square theta. So now we just need to show that this part is the same as 1 over cosec minus. This part we need to show that this is 1 minus cosec. We need to show that this is 1 over cosec minus sine. Let's see how we can do that. All right, this is a nice little proof. All right, it's easy to show that this is equal to this, but you cannot show that your right-hand side is equal to your left. The question specifically said to show that your left equal your right. If you prove that the right equal your left, you didn't answer the question. It said show this equal this. So let me see now, this part, sine theta over 1 minus sine square. As we said, looking at this part right here, we get the numerator already. We just need to show this is 1 over. We know sine theta in the numerator is 1 over cosec. Then what's 1 minus sine squared? This part is 1 minus cosec, 1 over cosec. This is 1 over cosec. And 1 minus sine squared. The cosec theta minus sine theta. Let's have a good look. We already get to our numerator. What I'm going to do up here, I'm going to expand out this denominator. I just want to check what that can be simplified to be. That denominator, which is cosec minus sine. If I have cosec minus sine, in reality, what I have is 1 over sine. I have 1 over sine minus sine. And if I have 1 over sine minus sine, in reality, 1 over sine minus sine is equal to, this is now 1 minus sine square over, I see it now, I see it. I see it, 1 minus sine square over sine. All right, we're nice. We're good now, we're good, we're good, we're good. We're good, we can finish it now. We're good. It was good to break it up. Now, sine theta over 1 minus sine square can be written as, so now we're multiplying by, put a bracket. You're going to say, why is this bracket here now? What is he going to do? I'm going to rewrite sine theta over 1 minus sine square as 1 being divided by, is 1 being divided by 1 minus sine square, 1 minus sine square theta over sine theta. All right. But then 1 minus sine square theta over sine theta, that part is cosec minus sine. This part is cosec minus sine. If you want me to show it, let's go further and simplify to show it. This will work out to be cosec. This will work out to be cosec theta multiplied by 1 divided by 1 minus sine square over sine theta. That's just 1 over sine theta. That's just 1 over sine theta minus sine theta. All right, and we put a bracket around here that the division is for here. All right. No, it's not so clear. And then this one over sine is cosec, and this is sine. So all of this works out now to be equal to cosec. This works out to be cosec theta multiplied by 1 divided by can be written as 1 over, now 1 over sine theta is cosec. This is now cosec theta minus sine theta. And then when you multiply them, cosec times 1 is just cosec. Nice and easy, soft. So this works out now to be cosec. This is just the right hand side now. So this works out to be cosec theta over cosec minus sine. Over cosec theta minus sine theta. Nice and easy. Nice and easy, soft. And this proves it. I know it's not in any particular order, and for 4 marks, I thought it would have finished somewhere up here, but we finally came to the conclusion, right, that it is indeed cosec theta over cosec minus sine. So we'll prove it. Now let's move on. Now it says hence or otherwise solve this equation. Hence meaning using what we know, cosec over cosec minus sine. Cosec over cosec minus sine is sec squared theta. So what they're asking you to solve is hence solve sec squared theta equal to 4 over 3. If sec squared theta is equal to 4 over 3, we can square root both sides to get that sec theta is going to be equal to the square root of 4 over 3. The square root of 4 over 3 is 4 over 3 square rooted. So we get sec theta is the square root of 4 over 3. That's going to be sec theta, the square root of 4 over 3. And remember, when you square root it, you get plus or minus. So it's going to be plus or minus 2 over root 3. And then sec theta, as we know it, sec theta is 1 over cos. And so that implies that if sec theta is 1 over cos, it is telling us that cos theta is equal to plus or minus root 3 over 2. So if cos theta is equal to plus or minus root 3 over 2, we want the solution in every quadrant. So we want the solution in all the quadrants. We need the solution in all 4 quadrants. Plus or minus means we need both the positive and the negative quadrant. So first we'll find the principal acute angle alpha, which is cos inverse root 3 over 2. So root 3 divided by 2, cos inverse that's pi by 6. This is pi by 6. All right, so we'll get pi by 6. Now over here, it's going to be pi minus pi by 6. And pi minus pi by 6 is pi minus pi by 6. So the angle in this quadrant is pi minus pi by 6. Angle in this quadrant will be pi minus pi by 6. The angle in this quadrant will be pi plus pi by 6. And angle in this quadrant will be 2 pi minus pi by 6. So let's write them out now. So therefore, we're getting that theta is equal to angle in the first quadrant, pi by 6, comma, angle in the second quadrant, 5 pi by 6, angle in the third quadrant, 7 pi by 6. Angle in the fourth quadrant, which is 11 pi by 6. So those are all the possible values for theta. Nice and easy, soft. Easy question. Lovely. Next one, it says express f of theta in the form r sine theta plus alpha, where r is greater than 0 and theta is between 0 and pi by 2. So first thing we'll find is r. R is going to be equal to the coefficient of sine plus the coefficient of cos, both of them squared. So it's 1 squared plus 1 squared, all square rooted. And so r is equal to the square root of 2. And so now alpha is going to be equal to tan inverse of 1 over 1. Alpha is just equal to tan inverse of 1 over 1. And tan inverse of 1 over 1 is equal to pi by 4. Nice and easy, soft. So that's what we have. And so therefore, f of theta is equal to the square root of 2, which is r sine theta plus alpha. So it's root 2 sine theta plus pi by 4. That's f of theta. Root 2 times theta plus pi by 4. Nice and easy, soft. And that's an easy 5 marks. Now it's a hence find the maximum value of f and the smallest non-negative value of theta for which the maximum occurs. Now, the maximum value of f of theta is always r. So you can tell them that the maximum value of f of theta, the maximum value of f is r, always that. All right, and what is r? The maximum value of f is r, and r was the square root of 2. R was the square root of 2. All right, so root 2 is the maximum value of f of theta. Now I want the value of theta for which the maximum occur. Now, the max occurs when the function is equal to its amplitude, maximum amplitude. So the max occurs when root 2 times the sine of theta plus alpha, which is theta plus pi by 4, is equal to root 2. That's when the maximum occur. This is when the maximum occur. The maximum occur when this is equal to root 2. And so the root 2 cancels on each side. And so what we get is the sine of theta plus pi by 4 is equal to 1. And so now we take sine inverse now. And so what we're going to get is theta is equal to, well, not theta. When you take that sine inverse, what you're going to get is theta is equal to theta plus pi by 4 is equal to sine inverse of 1. So you get theta plus pi by 4 is equal to sine inverse of 1. And when you take sine inverse of 1, remember that it's going to be in 2 quadrants. So it's equal to sine inverse of 1 or pi minus sine inverse of 1. Because sine is positive in 2 quadrants. All right, so we know that sine inverse of 1 is, I think that's pi by 2. Yes, pi by 2. So we get that theta is equal to pi by 2 minus pi by 4, because we can subtract the pi by 4. All right. And so theta is just pi by 4. We don't even need to check the other one. Theta is just pi by 4, because it won't be smaller than pi by 4. This is for the angle in the second quadrant, so you don't even need to look at this one. Let's just erase the or part. Theta is pi by 4. All right, nice. So that's that. Theta is pi by 4. So that's when the maximum occurs, when theta is pi by 4. Nice. Let's look at this part now. Part C, it says prove that the tan of A plus B plus C is equal to tan A plus tan B plus tan C minus tan A tan B tan C over 1 minus tan A tan B minus tan A tan C minus tan B tan C. Okay. So first, what we're going to do is break it up as tan A plus B, close that, plus C. All right, so breaking it up. All right. So now tan of A plus B plus C. Now we're thinking of A plus B as like a X. All right, so the tan of A plus B plus C is going to be the tan of A plus B. It's going to be the tan of A plus B, tan of A plus B, plus the tan of C, divided by 1 minus the tan of A plus B times the tan of C. Nice and easy. So this is what we have. So this is going to be equal to, simplifying the numerator now, the tan of A plus B plus the tan of C. The tan of A plus B is going to be equal to, we're just going to use that formula again. Tan of A plus B is tan A plus tan B. So it's going to be tan A plus tan B divided by 1 minus tan A tan B, 1 minus tan A tan B, plus the tan of C over, now this part again becomes now 1 minus this tan A plus tan B. We're going to put all of this right here again, which is 1 minus tan A plus tan B over 1 minus tan A tan B and minus tan A tan B plus tan C nice and easy, soft. So this is what we have. And so now, all we have to do now is work out this, simplify this. So now to simplify this, we'll multiply through by, we'll bring up this, make it one fraction in the numerator. So the numerator, it's going to become tan A plus tan B. It becomes tan A plus tan B. And when I multiply the numerator here, it becomes plus tan C plus tan C. And then multiply this, it becomes minus tan A tan B tan C. I don't know if I can write out that, so let me write it right here. Minus tan A tan B tan C. That's what we're going to get right here. Let me see. Tan C times this, tan C times this, yep. And then all of this, of course, is being divided by 1 minus tan A tan B. All of this is divided by 1 minus tan A tan B. And then everything again is divided by, so this, let me put a bracket to show that this is for the numerator part. Then now to simplify the denominator part, let me see what we're trying to show. 1 minus this. Okay. So multiply up this again, multiplying up this times the 1, you're going to get, in the numerator you'll get, this times 1 will give 1 minus tan A tan 1 minus tan A tan B, yeah, minus tan A plus tan B. Then we'll multiply up this times tan C, we're going to get 1 times tan C is just plus tan C plus tan C minus, this becomes tan A times tan B times the tan of C. And all of this is divided by 1 minus tan A tan B. And then remember, when you have these fractions, how you do it. If you have a fraction being divided by another fraction, it's like this fraction multiplied by the reciprocal of this fraction. And so the middle portions are going to cancel each other. What am I saying? So this right here, this 1 minus tan A tan B is going to cancel the 1 minus tan A tan B. We're going to left back with the numerator over this part. It's going to work out to be equal to, I'll get what them want. See there? Yeah, man, we get it. It's going to be equal to the tan A. Let's write back the numerator up here, the tan A plus the tan B plus the tan C minus tan A, tan B, tan C. And this is all being divided by over 1 minus tan A, tan B minus or tan A, tan C minus or tan B tan C. All right, nice and easy. Tan C, see here the tan C is positive, then you have the tan A, tan C, tan A, tan B. All right, then we can get out that. Yeah, then that proves it. And this is how you prove the right hand side. Nice and easy. This proves it. Soft. All right, that's the proof. Nice. We'll finish that. That's that part. And that takes care of question 3. Now reach question 4, which is some more trigonometry. It says, given that the sine of theta is x, show that the tan of theta is x over the square root of 1 minus x squared. So the sine of theta is x, show that tan theta is x over the square root of 1 minus x squared. So first thing I'm going to do is draw my triangle. I work well with triangles. The angle is theta. Hypotenuse is 1. This is really x over 1. And the opposite is x. And so I need to find the adjacent. Let's call it adjacent A. The adjacent A is going to be equal to the hypotenuse square, which is 1 square minus x squared, all square rooted. That's the adjacent. And so what we're going to get now is we're going to get that the tan of theta, the tan of theta is equal to the opposite of x over the adjacent A, and the adjacent A is this, the square root of 1 minus x squared. So that wasn't nothing to show. That's all I wanted us to do. So finish. Tan theta is opposite over adjacent, so we're done. Nice. 3 marks. Next part says, hence or otherwise determine the Cartesian equation of the curve defined parametrically by y equals sine 2t and x equals sine t. Hence, I'm not going for the hence, I'll go otherwise. I don't even want to utilize that. So y is equal to tan 2t. Y is equal to tan 2t. And I'm going to rewrite tan 2t as sine 2t over cos 2t. That's why I said I'm not going the hence route. I'm just sticking with identities that I know. So sine 2t over cos 2t. And then I know that sine 2t is 2 sine t cos t. So this is sine 2t, 2 sine t times the cosine of t. And then I know that cos 2t is 1 minus 2 sine squared t. That's cos 2t, 1 minus 2 sine squared t. And this is y. And so all I have to do now is substitute for sine t and cos t. So y is equal to, substituting for sine t, sine t. I'm going to think of t as theta. So sine t is x. So it's going to be 2 times x. What will be cos t? If sine t is x, then cos t, I'm just going to write down as cos t from here. Cos t would be adjacent over hypotenuse. So cos t is going to be the square root of 1 minus x squared. It's x times cos t is the square root of 1 minus x squared. That's going to be cos t adjacent over hypotenuse over 1 minus 2 times sine square t and sine square t. Sine t, so it's 1 minus 2 times sine square t. Sine square t will just be x squared. All right. So this is what we get for y. Can I simplify this? Yes, I can. So y is equal to, well, I'll leave it like that. That is y. All right, I could simplify it I'll leave it like that. So y is 2x times the square root of y is 2x times the square root of 1 minus x squared over 1 minus 2x squared. Nice and easy, that's it. Nice. All right. Well, let's look at the next part now. It says, calculate the lengths of u and v respectively. Give us u and it gives us v.